Hey everyone, FusedVR coming at you. Hope this video finds you doing super well and staying safe. This is our part 2 to our Thanos-like snap effect, and on part 1 we just went over the universal render pipeline, and quite frankly that's the really only part you need in order to follow along with this, is just have something that works with universal render pipeline. And in this video we're just going to be going through a directional dissolve, so I wanted to show that off really quick here, and then we can just go into a project that just only has universal render pipeline and build this out. So if I look on any of these objects here, you'll see I have a material that's set to work with the directional dissolve. There are a lot of properties here. We'll not be building all of the properties in this specific video, but the core kind of stuff here is we set a direction. So very simply here, let's say we want the Y direction, for example. You can just set that direction, and then you just kind of go through the clip percentage. So if you want 50% in the Y direction dissolved, you can do that all the way up to 100%. And we can go ahead and flip that as well. So if this is in the negative Y direction, you'll see it kind of fills in the other way. Again, 50% is still about here, but now the top half is missing. And you can do this for any of the directions here and for any 3D object with any material. So that's what we're going to go ahead and build here. And the other thing I wanted to mention before we go ahead and dive into the video is most likely I will probably end up doing the third part a little bit later, because I wanted to play around with some Half-Life effects, and I was kind of curious. Let me know in the comments below if there are any specific effects that you would like to see from Half-Life as kind of small tutorials. I was thinking of doing Jeff, just because that was personally my favorite level from Half-Life, but I'm curious to know what you guys thought about Half-Life, and as well as if there are any interactions from Half-Life that you would be curious to see developed in VR. So let me know about those in the comments below, as well as if you have any questions about anything in this video. And if you can do me a favor and smash the like button, that really does help out the channel a ton. So with all of that said, let's go ahead and dive right into things. Okay, so I've gone ahead and opened up the project we used in the last video, and that's just kind of to use universal render pipeline as a basis here. And quite frankly, you don't need to watch the whole video. I'll go ahead and link it, but it's just realistically the first 5 or 10 minutes of that tutorial, and I'll leave timestamps for that just so that you can quickly go ahead and get yourself up to speed. And so, but yeah, we really just need universal render pipeline to be working for us to do this. So first thing before we go ahead and dive into the tutorial in and of itself is we'll be using basically this specific tutorial on how to create the directional shader. And the reason for that is honestly, so they have basically a surf shader here that will just be going and modifying this a little bit to work with shader graph. That's really all there is to it, and this just kind of serves as a nice basis. I mean, if you'd watched the whole previous video on universal render pipeline, we actually did something very similar where we go ahead and we took the Oculus hand tracking and we made that shader work with shader graph. So we're going to be doing something very similar here just to get this directional dissolve. This works honestly really well, so I figured it makes sense to use it as a basis, and there's really not that much we have to do, which is actually really convenient. So before we dive into the shader graph part, and honestly there's not too much to it, so it'll be fairly simple, which I'm really looking forward to. Make sure on your universal render pipeline, go ahead, disable the scriptable render pipeline batcher. Now the reason we have to do this is because we'll be working with like specifically object space for our shaders. And as a result, once if we have this batcher here, the batcher starts combining kind of all our models into one giant mesh. You won't see this within Unity, but if you put it onto Oculus Quest, you will actually notice that that's what it's doing. And as a result, none of our calculations will actually work on a per object basis. So we have to actually go ahead and disable this batcher here. With that out of the way, we can actually go ahead now and start writing our shader graph. So let's go to Create, go to Shader, and go to PBR graph. Let's call this, all right, just called it Directional Dissolve. Go ahead and open that up. One thing I should mention is if you don't want a directional dissolve effect and you just kind of want something that's based on noise, Brackeys has a really good video on just creating a simple dissolve effect, and I highly encourage you to check that one out. I think he does a really nice job explaining things. That's kind of how I started with getting into shader graph in and of itself, was through that specific video, and that's kind of where everything kind of fit together. So here we have our PBR master here, and so let's just kind of quickly walk through this. Here we have a bunch of properties. We're actually only going to be using these 4 specific ones: the color, main texture, dissolve amount, and direction. And he has an emission here, and so the emission, if we go back to the effect at the top here, is what's kind of creating these kind of particle effects here based on the noise. I'm going to be skipping that for now. Quite frankly, you can do the emission in a whole bunch of ways. Where I personally, I'll probably end up showing the final effect on screen right now, just so you can take a look. I ended up doing the emission slightly differently from the way he's doing it. Either way is fine. It's really not a big deal, but just for simplicity's sake, we're just going to be sticking to these 4 core properties. And from there's just a lot of boilerplate. He has a vert shader here, which quite frankly we don't need to do, and all he's really doing here is he takes the vertex, so this is in object space, and he's converting it to world space. Now, so he specifically is doing everything in world space, and world space is honestly fine, and it would have probably worked with the batch. I didn't test this, but I think it would have worked with the batch enabled. But the one downside here is if the object is moving, then as a result, it starts dissolving with the speed of how fast it's traveling, as opposed to ignoring the speed. In that sense, that's kind of the key difference. If you want that type of effect where if it's moving, it keeps its speed as it's dissolving, you could do that. But if you just kind of want it to be without the speed, then you're going to be sticking with object space, and you can ignore that. And so that's what we're going to be doing, which is with skipping the object space here. And with shader graph, we actually don't even need to do this. We can honestly just switch between those two really easily, and I'll show you how to do that just in a second. From there, he has a random function which he uses for emission. Again, we're not going to bother with that. And really the core rest of it is this, plus of course the setting properties here. The one thing that might be a little foreign is this clip function if you've never used shaders before. And clip is actually a very useful function. It basically says if the value is less than 0, we'll go ahead and ignore this vertex and move on to the next one. If it's, or I guess for this, since it's shift shader, we'll ignore that fragment. If it's greater than 0, then we will keep it and continue moving on with some of the outputs here. So it's very kind of fast and easy way, if you will, to just kind of clip out certain vertices from your model. We don't have that with shader graph, but we can emulate it in a kind of slightly roundabout way, and I'll go ahead and show you how to do that with this specific video. So first things first, let's go ahead and let's set up all the properties real quick, and I'll speed through this just to save some time. Okay, I've got added these properties here. Just for defaults, I'm going through, I set this to 0, but it's a slider from -3 to 3. And for the direction, I'm just going to be setting it to 0, 1, 0. You can set this to whatever you'd like. I find the Y direction probably the easiest to test with, so I'll be sticking with that. You could also go ahead, let me do this. I'll set this to white, and we have a texture. If you want, set up a texture. That doesn't really matter for our sakes. So that basically emulates everything here. So we can now get started with the surf shader. So the first thing we need to do is go ahead and calculate our color. That is super easy. Just go ahead, drag our texture in here. We need to sample it. So you can go ahead, sample it. And let's drag our color. And we just multiply everything together and drag that into the albedo. Okay. So this is kind of very standard for setting up any albedo if you want to multiply the texture with the color here to just kind of create a PBR-esque effect. So Nothing terribly new here, but this is just in case you need it to go ahead and set up any material. You can do this for really anything, normals, etc., etc. Next, we have our test here. So this is going to be the more important part. So let's start first with the dot product. So that's kind of the most inner function here. So that's going to be the dot of the, so they're using world position, we'll be using object position, and the normalized direction. So first things first is we need to get the position. So you can do that very easily, just create a node for position. And unlike what he has to do, which is convert object space to world space, we can actually very easily do that right here by just picking which one. So if you ever want to test things out between what world might look like, just switch that once you have this working. But we'll be using object space here, and we need the direction. So let's go ahead and take the direction here. First, actually, we need to normalize this. There's the normalize. And this is more just for cases, let's say you set the direction to like 1, 1, for example. It'll go ahead and normalize this down to a unit vector. But we'll just be doing 0, 1, 0. Next, let's go ahead and do a dot product here. Okay. And from there, we have this function here for adding +1 divided by 2. You can go ahead and do that. That's one way to do it. And but the main reason, if you ever see this is basically a remap. So specifically, oops, wrong remap. But specifically, what we're doing is we're remapping from the -1 +1 space to 0, 1, 0 to 1. So specifically, if you just look at the range here, for example, so +1 of -1 would make it 0. And then for the max range here of 1, that would become 2. So we would divide by 2 to get a range from 0 to 1. So that's basically all that's happening here, and we can just save some time by just plugging this into a remap function. And last, all he's doing here is a test to, he takes the value, he takes the value from what he just calculated from the remap. So that's this test here, that minus the dissolve amount. So we have dissolve amount here, we have this remapped value here. So all we need to go ahead and do is we'll run, you can run this through a subtract, or alternatively, it's probably easier to just run this through a comparison function. And we will set this to greater than. So it just says if remap is greater than the dissolve amount, then it'll be true on this side, or otherwise it'll be false. And from that, we can actually go and put this into a branch node. And let's just swap these here. Make some, just a little bit of space, not too much. Okay, so why pick 0 and 1 for true and false? The reason is we need to pipe this into the alpha clip. Now, what alpha clip is it basically says, instead of, so this PBR master here is not actually set to be an alpha. It is set to be opaque. So what that means is we can actually use the alpha channel to decide whether or not to clip a specific vertex, which is exactly what the clip is doing here. And what it says is if the alpha value is, or rather, if the alpha value is greater than the clip threshold value that we've piped in, it'll keep it. If it's less than, it deletes it. So if we go ahead now, and I think there's like this weird issue where these, if you minimize and maximize, the kind of default values disappear, but whatever, this is an easy way to get around that. If we set this to say 0.5, for example, what it'll say is if it is true, then we're going to be clipping. If it's false, then we will keep the value. And now actually, so you can see here, if I set the default value for the dissolve amount to 1, everything disappears. If I set it to half, you have just the top half. If you set it now to 0.25, you see here just this one kind of small clip of this disappears. And if we set it, of course, to 0, that changes. And also, so let's keep it at 0.5. So that's the half here. And you can also go ahead now and change the direction. So let's say if we want this in the x-axis, boom. If you want this in the x and z axes, you can get that too. Doesn't make a whole lot of sense with a sphere, but you get the idea. Let's go ahead and set this back to 0, 1. Okay. All right. And one nice little thing I think for directional dissolves is if we go ahead and set it to two-sided, it's just a little bit easier to see the dissolve in action as kind of the backside disappears. And yeah, honestly, that pretty much does it for the effect. There's not too much else we need to do. You can go ahead and save the asset here. And let's give this a try on something a little bit more complicated. So if we say create a cylinder, for example, and let's create a material. Let's go ahead, I just called it dissolve, drag the shader onto it, and then drag that material here. And as you can see, half of it is missing. That's not surprising. And you can play around with the shader here. Now, you'll see that I've set the range from -3 to 3, and the reason for this, more specifically, is because most of the simple objects that we have are going to be well designed such that their object space kind of fits within this unit space of 0 to 1. But not all models will fit that criteria. So let me go ahead and bring in a different asset so that we can try that. Okay, so here's an FBX that I pulled off of Mixamo. Just go here. You can set all the materials and stuff. They're all embedded within it. And then let's go ahead and drag our material onto here. So, okay, here we go. So you can see here it's at about 0.5. However, it only disappears by 0.108, 105 approximately. And if we pick a different direction, let's say 1, for example, now it's disappeared by 0.91. And the reason for that is because, again, we're not dotting within unit space. So these values, while ideally when you remap them, it's from -1 to 1, that's getting remapped to 0 to 1. That's not always the case. And that kind of, again, depends on the model specifically. But if we go ahead and open this up, this remap doesn't guarantee a value from 0 to 1, especially if we're outside of this -1, 1 range. So for that reason, that's why we have the dissolve amount set to -3 to 3. What I did actually in my final one, and just to save time, I'll just go ahead and show it, is instead of kind of defining these -3, 3 range, I actually define a min and a max, and then we create a slider that goes from 0 to 1. So in that regard, you kind of tweak the parameters, if you will, so that the range is correct. And in code, you can actually just slide the slider from 0 to 1. And that's probably, I found, the easiest way to just kind of make things consistent across the board. Otherwise, you're just going to have to predefine on a model-by-model basis what the min is, what the max is for each model. Kind of gets a pain when you're dealing with C# scripts. But by having kind of just defining a min and max as constants basically for a given material, and then having a slider that goes from 0 to 1, you save yourself a lot of headache. So that's what I ended up doing, just to save yourself headache with the math. Of course, if you're creating your own custom models and you can define the unit space to be 0 to 1, that'll also save you a lot of time. But I prefer to have the shader to be as kind of generic as possible, and I think this kind of fits the bill as far as, yeah, you need to do a little tweaking, but at the same time, it saves you a lot of headaches down the road. And again, you'd have to do the same thing if this was set to world space, and there's no getting out of unit space as far as that goes. So yeah, that kind of basically covers everything as far as the dot products go. Again, in the final shader, we do a whole bunch of things as far as emissions go, and quite frankly, if I go through everything in the final effect, it would take way too much time. But I think this serves as a really good basis for just getting something up and running that I think is a pretty cool effect when kind of put together, and then you can just kind of quickly and easily slide through it. And then from there, you can access things through C# scripts. I should probably mention, when you're accessing things in C# scripts, it's going to be using this reference name, so probably worth changing to something akin to, say, this, or if you want this to be consistent with shader naming, change it with an underscore. But yeah, I think that pretty much wraps it up for the video. Again, I wanted to keep this fairly short, but just to get you guys a pretty good overview as to how you can actually go ahead and create a directional dissolve shader. So if you guys have any questions about this, make sure to leave that in the comments below. And also, if you found this video helpful, make sure to give this one a like. And yeah, that pretty much wraps it up for the video. So thanks so much for watching, and I'll catch you guys in the next one. It's been FusedMan, and I'm signing out.